Okay, this is the Semester 2 review, Day 2, circles. Taking a look at this problem here. It says we are told that this segment, AB, is the same length as the segment CB. And we are asked the measure of arc CE is 50. We want to specifically find the measure of angle BCE. So BCE. So we want to find this whole angle right here. Now, the key to finding that one thing is to simply go through and find everything. In other words, it's a squeeze the sponge problem. Okay, so we're going to squeeze that sponge. That's my rendition of a sponge, squeezing out water. Okay, so let's start always with what we know for sure. We have here a diameter, which means that has to be 180. And if you frame this angle back here, we're going to pretend we're going to frame it. If you have Post-its handy, do so. So I'm going to frame it like so. Why am I framing? Because it's inscribed. How do I know it's inscribed? Its vertex is on the circle. And whenever you have a vertex on the circle, you can frame. When I frame, I see that I'm grabbing 90 degrees here. And if I'm grabbing 90 degrees, 180 back here, that means this right here is 90. Another thing I know is that if that's 90 and I have two equal sides, these two angles have to be equal. So it's 90 divided by 2. So that has to be, of course, 45 and 45. Let's ask ourselves, what else do we know? This angle going this way if you look carefully, it's grabbing 180 degrees this way, which means back here, that's also 90. Next, I have another inscribed angle right here, reaching out and grabbing the 50. So that means back here is half. It's 25. Your final goal is therefore, using this information, you want to find this still light pink missing angle, and then you have the 45 and use that to find your target angle, which is BCE. Let's take a look at number 7. Number 7. We have a bunch of tan-tan angles. So remember, when we have a tan-tan angle, you have one tangent to another tangent. We know that the arms of the tan-tan angle are equal. So this works really, really well if you have colors. So all I'm going to do is just color code the tan-tan angles from you. So from there to there, H to J, and H to N, that's a tan-tan angle. From here, K to J and K to L, that's a tan-tan angle. And from M to L and M to N, that's a tan-tan. Now, you find everything possible. And after you find everything, then narrow it down and specifically solve for X. Okay, number 8 says find the measure of the numbered angle. The numbered angle is right there, 3. And we're given 2 arcs. One arc here, and 1 arc here. Now before we do anything else, we have to ask ourselves what kind of angle is going on here. If you look carefully, this is a chord. Let's write down the equation for a chord. A chord angle looks like this. Angle equals arc plus arc over 2. And be really, really, really careful here. This blue angle is not this. It's not. Look very closely where your given information is. The involved arcs are here and here. That means that pink angle there that we could find is this one right there. But Miss Way, that's not the one we're trying to find. That's okay. Remember, always find what is easy to find. So we're going to find the pink. So that pink angle equals arc plus arc over 2. We circle plug chug. 1 arc is 105. The other arc, 135 over 2. We end up with 240 over 2. Divide that by 2. We get 120. So this angle right here is 120. Warning, that's not the angle you're looking for. What I'd like you to do, one last step. Put your pencil right there. Ready? Sweep. You know that's 180. Go ahead and solve for the missing angle. Going to do number 11 here. Okay, we want to find x. All right, so first we need to identify what kind of angle we have going on here. This is a secant. This is a secant. So we have a secant angle. And a secant angle, we know the angle equals big arc minus little arc over 2. Now before we go on, I want to see what you do. Trace, where's the big arc and where's the little arc in this equation? I want to see if you can physically identify those yourself. Trace them. I'll color code them for you in about 20 seconds. Okay, let's see what you identified. Your big arc is this arc right here. Problem is you don't currently have it. Your little arc you already have. So the little arc is easy here. It is the 38 degrees. Question is, how do you get the big arc? Ready? Put your pencil here. Sweep around. Keep going. Keep going. Keep going. Ask yourself what you know by that. Once you ask yourself that, then find the blue and finish the problem. Okay, number 15. Says write an equation for a circle with a diameter that has endpoints at -10, 1, and -8, 5. Round your answer to the nearest tenth. We're going to write an equation of a circle. So let's start by writing the basic equation of a circle here. And that's x minus h squared plus y minus k squared equals the radius squared. That's the equation of a circle. So you ask yourself, what is it that you need? Well, we need an h and a k, which is the circle center, and we need a radius. So we're missing, right now, we're missing everything. Let's look at what we've been given. We've been given a diameter that has endpoints. So let's start just by kind of graphing what we have here. We have endpoint diameter at -10, +1. So over 10, up 1. I'm just going to label that. That's -10, 1. And then another endpoint at -8. So left 8, +5. So this would be the diameter of a circle. So technically our circle is going to look something like this. It's a diameter. So imagine that's the fattest part of the circle. We're just going to sketch around. Whoops, I am doing a bad job of trying to sketch this. Okay, now remember, there's only two things we need. We need the h, the k, and the radius. So let's put a dot at what the center would be the center of the diameter. So we need our coordinates here, which is the center of the diameter. That would be our h and our k. Let me keep my variables and my color straight here. That would be our h and our k. So notice that the middle of the circle is the midpoint of the diameter. So real simple concept here. The center of the circle is the midpoint of the diameter. So therefore, if we find the midpoint of the diameter, we'll have our h and k. So here we have -10, 1, -8, 5. We're going to stick that in the midpoint equation, in which we add the x's, divide by 2, add the y's, divide by 2. Just circle my x's, -10, -8. Box my y's, 1 and 5. This ends up being -18 divided by 2 and 6 divided by 2. So by this we get our h, which is going to be -9, and our k, which is going to be +3. So our h and k is -9, +3. Then the only other thing we need is the radius length, which would be from here to here. And to get the length, we're going to use the distance equation. Length is distance. So we're going to find the distance between this center, which is -9 and 3, and either endpoint. It doesn't matter. We're going to use -8 and 5. We're going to make a distance template. Looks like so. And remember, it's x minus x, so we plug in our x's. So I have -9 minus -8. Box the y's. Going left to right, that's 3 minus 5. You solve there, show your own work, that'll get you the radius, and then you design your equation. So we have our h and k here. You find your radius here, and then you plug in your h and k here, and your radius over there, and clean it up, and you have your equation.